Let's look at another example with a graph. In this one, we're trying to solve two different inequalities again. So before we even get started on this, let's go through and mark our x-intercepts and draw in the section boundaries. Here's one x-intercept that's at -5, 0. Here's another one at -3, 0. Here's one at 1, 0. And here's one at 4, 0. So this time we have 4 x-intercepts, which means we're going to have more sections in our graph than we did for the last problem. So I'm going to draw a dotted vertical line through each one of these x-intercepts so that I'm splitting my graph up into different sections. So now I have 1, 2, 3, 4, 5 sections in my graph. I'm going to go through, and for each one I'm going to write the interval that goes with it on the x-axis. But this one is going all the way out to -infinity, so my interval would be -infinity to -5. This one's going between -5 and -3. Remember, when you're doing this, you're just using your x values. This one goes between -3 and +1. This one goes from 1 to 4, and this one goes from 4 to infinity. Since I know I'm going to be interested in whether the points are above or below the x-axis, I can just go back for each one of these and write that in. In this interval, the points are below the x-axis. In this one, they're above. In this one, they're above again. In this one, they're below. And in this one, they're above the x-axis. So I already have most of the work done to solve both of these inequalities. Let's start with this one. The main thing we need to do now is interpret what this means. Since it has a greater than 0, that means we want points above the x-axis. And since it has an equals, we also want the x-intercepts included. This is saying that we want the points that are above or on the x-axis. We can pick out all the intervals down here that had points above the x-axis. That would be this one, and this one. And then for each one of these, we want to include our x-intercepts. So we're going to use brackets for our endpoints instead of parentheses. If we include this interval, we're going to put a bracket with the -5 and the -3. That way both of those two x-intercepts are included. Then for the next one, we want to put a bracket with the -3 and the 1, so that both of those x-intercepts are included. And then for this one, we're going to put a bracket with the 4. We don't ever use brackets with infinity or -infinity. Now this is one way that you could write this solution for this one. Another thing to notice here is that since technically we went all the way from -5, we included the -3 in the middle, and then we went all the way to 1, we could take this part and write it together as just one big interval from -5 all the way to 1. This would just be another way to write that solution. Either way is fine though. For this inequality, this one we're just looking for points that are below the x-axis. So we're going to go back to our graph and pick out the intervals that had points below the x-axis. That's this one and this one. This time we're not trying to include the x-intercepts, so we're going to leave everything as parentheses. That gives us -infinity to -5 and 1 to 4. Let's look at another example now where we don't already have a graph. For this one, we can sketch in the graph of our polynomial. Once we have that, we can follow the same process that we did on the other examples where we already did have the graph. Now this requires us to go back a little bit to earlier in the semester when we were talking about graphs of polynomial functions. One thing that we're especially interested in here is the zeros, or the x-intercepts. This one is already in factored form, so we should just be able to read off the zeros by thinking about what would happen with each one of these factors if we set it equal to 0. This out here counts as a factor. The 0 for that would be x equals 0. For this one, we would get x equals -2. For this one, we would get x equals 3. Now remember when we did this before, we talked about finding the degree of the function by adding up the multiplicities. For these ones, the multiplicities are each 1, because each one of these factors technically has an exponent of 1. So each one of those is 1, and if we add those up, that gives us 3, which is the degree of our polynomial. The other thing that we can tell from this, because we have a -2 out in front of this, our leading coefficient is -2. And these two things together will tell us what the end behavior of our graph is. And especially if we're going to graph this by hand, but even if we're going to graph this with our calculator, knowing what the end behavior is in advance will help us to make sure our calculator graph is showing us everything we need to see. If we've got a negative leading coefficient, that tells us that the graph goes down on the right. If our degree is odd, like it is here, then our behavior on the left end is going to be the opposite of this, which means it's going to go up on the left. This is how we could describe our end behavior. If we want to draw a little picture of it, we'd be going up on the left and down on the right. So it would be something like that. Now what we can do is take our 3 zeros as x-intercepts and plot them on the graph. So the first one we would come to going from left to right would be -2, 0. And then we would come to this one at 0, 0. And then one more at 3, 0. We know we would start out on this left end up here. And for all of these, since the multiplicity was odd, each one of these is going to be a cross, which means the graph crosses the x-axis at that point. So we're coming down from up here. We're going to cross through the x-axis here. Then we're going to come back to the x-axis here and cross again. And then we're going to come back to the x-axis here and cross again. So our graph is going to look roughly something like this. This really doesn't need to be exact whatsoever. What we're really interested in is where our x-intercepts are and whether our points are above or below the x-axis. Now that we have our graph, we can draw in a dotted vertical line that goes through each one of these x-intercepts. Here's the one through -2, here's the one going through 0, and here's the one going through +3. That splits our graph up into 4 sections. I'm going to go ahead and write the intervals that go with each section. This one goes from -∞ to -2. This one goes from -2 to 0. Remember, for these, I'm just looking at the x values of these x-intercept points. This one goes from 0 to 3. This one goes from 3 to infinity. And if I look at my different intervals, in this one, all the points are above the x-axis. This one, they're below it. This one, they're above it. And in this one, they're below. I've got all that work done with the graph. Now I'm going to go back and see what my inequality was in the first place to figure out what it is I'm looking for. Since this was a less than or equal to 0, that means I'm looking for points below the x-axis, since this was a less than. And then the equals means I'm also going to include my x-intercepts. I'm looking for these intervals where I said the points were below the x-axis, this one and this one. To include my x-intercepts, I'm going to make each one of these into a bracket instead of a parentheses. So for this one, I would have brackets for the -2 and the 0, and this one I would have a bracket with the 3. And that's my solution.